probability. Start again. Probability. So we can either have experimental probability, where you're actually carrying out experiments, or you can have theoretical probability. There are main two situations that we've got. Theoretical takes into account just the facts of what's going on. So, for example, a dice is 5, only one of them's a 5, so the probability of a 5 is 1 out of 6. And if you did an experiment and you rolled that particular dice, you rolled a 5 20 times out of 70 times that you did it, then your probability to roll a 5 on that dice would be 20 out of 70. Okay? So, terminology, the sample space is U, so that's our possible outcomes. And we've talked about our universal set in the past, yes? Like when you were done GCSE. Your universal set used to have a curly E. So essentially your U is your universal set, and that's now a U. Which gets a bit confusing because we are going to be linking probability with sets and Venn diagrams. And so this does look like a union sign. So I apologise in advance. You need to make sure that you're comfortable whether it's a union sign or whether it's that universal set. And we also talk about events. Okay, the event, it's not a party we're having, it's what we're actually looking at. So, bowling a 6, looking at 4 out of the hat, whatever it is. Okay? So the probability of an event is the number of ways that something can happen over the number of members in the sample space. So how many possibilities are there? Probability of an event and its complement. So remember that complement, so if we have event A, its complement is A dash. Yeah? And the probability of those two events added together always equals 1. Okay, so the total probability of something happening or it not happening is always equal to 1. If you ever get a question, a probability question asking you for the probability of an event, you can never have an answer of more than 1. So if you have an answer of more than 1, you've done something wrong. If they're talking about how many times would you expect something to happen, obviously that can be more than 1. Okay, because they're asking you to say how many times an event is going to occur. So I'm just saying that because some people say, oh, my answer can't be more than 1. It can if they're asking you for the expected number. Alright, combined events. So we've got 2 events, A and B. Okay. The 2 main situations we're looking at is that both events A and B occur at the same time. Okay, so that would be the intersection. So I've done a little picture of it as well. So it's saying that A and B is happening at the same time. A union B means that A occurs or B occurs. So it can be either of them. Yes? You're all happy with those? Yeah? Note that in the union of the 2 sets, it will include the case where both A and B occur. So it's everything. So it's not or, it's everything. Considering the probability of A or B occurring, we see the N. Remember the number means the number of elements in that set. Is this all familiar? So the number of things in the union would be the number of things in A plus the number of things in B. But why do we have to subtract this?
Because we didn't that.
Yeah. Because you've already included it, yeah? Because if this was our A, we've included the how many are in there, and then we're doing a B, and all of those in there, obviously I've done that bit twice. Yeah, so that's why you've got to make sure you subtract that. Okay, we good with that? So obviously, if that's the number of things, then that follows that the probabilities of the union is going to be the probability of A plus the probability of B, subtract the probability of them both happening. You get given this, so you don't need to learn it. I've got skills to start. Oh, that's really annoying. Alright, here's an example. A card is selected at random from a pack of cards. When I teach GCSE, I need to make sure that people are comfortable with cards and what's in them. Not so much? No? Okay, so let's go over the quick run through. To be honest, it doesn't happen as much in IB level. They don't normally go to the pack of cards. But let's just make sure that we're comfortable just in case. In a pack of cards, how many cards are there? 52. Okay. What comprises this pack of cards?
You have your number.
You have
four
suits, a king,
black
and
and
a
red.
jack.
Okay, so we've got 4 suits. We've got, what are they?
Spades,
Spades,
clubs.
I thought spade. That wasn't bad.
That's pretty good.
And spade, a class, diamonds, and a heart. What's special about these things?
Oh, they're black and red.
Some of them are red, some of them are black. How many are red? 2 of the suits. So in other words, half the pack's red and half the pack's black. Yeah? And then on each of those suits you have which cards? King, Queen, Jack. Okay, so you're going to have King, Queen and Jack for each of them. And then 2 ace and 2 to 10. Yeah? This board is apparently fixed. So, sometimes they talk about a picture card. They sometimes include the ace in the picture. I would like and would hope that they would be more confident, consistent in saying face cards. So a face card would be a king, queen and jack. Because normally I would only think of a king, queen and a jack as a picture card. But some people say, but the ace is different, it looks a bit different, so they want to include that as well. So it's tricky, as I said, face card makes it clear it's just the king, queen and jack, so they faces.
Are the jokers included?
No. So whilst they're obviously always included in a pack of cards, they wouldn't be included in the competencies. Good?
Yep.
Alright, so the other thing with probability is this is the one time you don't have to simplify your fractions. Okay, so if you have a fraction and it can be simplified, you don't have to. Now most textbooks do simplify them, which is, so you need to know whether yours is done correctly or not, but you don't have to. Although, to be honest, it does get to the point, especially at this level, they tend to use decimals more than fractions. Okay, so we're aware that we are probably using decimals more than fractions. So anyway, go back to this example. So a card selected around a card, find the probability it's a king. Okay, so we say how many, it's often sometimes easier to start with our denominator. We'll talk about the pack of cards, so we've got how many in a pack. So that's going to be our denominator. And then how many of those cards are a king? 4, because there's one of each suit. So it's 4 over 52. Question done. Check. Yeah? As I said, I've simplified it for you. This is more writing additional notes. I've pretty much filled everything in for you. But write extra stuff if you are thinking stuff as we're saying. And probability of a heart. Heart. How many of them are hearts? 13, yes. Or, to be honest, I probably would have gone straight to 1/4 because I know there are 4 suits and only one of the suits is a heart. Yeah. But you've got options. The king of hearts. So here, we're talking about the fact it's a king, but it's also a heart. Okay? So, you've got a few different ways of doing this, but essentially we've got only one of them out of 52. Yes, there's only one king of hearts now. Either a king or a heart. Okay, so this is where you've got to be careful because we're saying either a king or a heart, which means that we would take the probability of the king, we would take the probability of the heart, we can add those two together, but we have to then subtract this probability where we've taken it into account twice. Does that make sense? Yeah, because the king of hearts is sitting into both of those situations. So we've got probability of a king, probability of a heart, subtracting the probability of both of them gives you 16 over 52 or whatever. Okay, fine. Mutually exclusive events. If two events are said to be mutually exclusive, it means that they have no outcome in common. Okay? So there's no intersection. So mutually exclusive events often are drawn in sets like that, because there's no intersection. So here our union would simply be A plus B, probability of A plus B. Because there is no intersection, then we don't have to subtract. Yeah. Exhaustive events, and they're said to be exhaustive if no elements in the sample space are not included. So remember when we would have looked at sets and Venn diagrams, you have stuff like this, and then you've got some things outside. Mm-hmm. This exhaustive events means there's nothing outside. You've got to be in your sets. Yeah. So in other words, the union would add up to 1. So everything is happening in that situation. Kind of example you might have, we're given that the probability of X is 4/5, the probability of Y is 1/2, the probability of the intersection is 3/10. Show that the events X and Y are exhaustive. So we're going to use this formula that we are given to help us. Right, I've changed the letters for you because we've got X and Y. Obviously you don't have to do that in the exam, but I'm just doing it now so you're more comfortable with it. So we've got the union of X and Y, probability of X plus probability of Y, subtract the intersection. So we're told the probability of X is 4/5, probability of Y is 1/2, probability of the intersection is 3/10, gives us 1. So the union 1, so it means that they are. It means that everything is 6. I might stop there and just get you to do some questions now. Conditional probability is starting to get into the slightly hard stuff that you may or may not have covered to this point. So, stop it. I don't know.